Okay, so our speaker tonight is Dava Sobel, and I will start out by mentioning she is an alumna of the Bronx High School of Science, and I bring that up because this institution has produced an unusually large number of professional astronomers, as it turns out. Her career is focused on science writing, and she's had a position as a science reporter for the New York Times, and has also been a long-term contributor to publications such as Discover, Science Digest, The New Yorker, Audubon, and the like of those. She has a number of nominations and awards for her work, and over the past few decades, she has been producing books roughly every 4 to 5 years involving different realms of the history of science. First publication working with Frank Drake, and others with quite lengthy titles, but they're quite descriptive and intriguing. And so I'm going to read these because if you're not familiar with her work, other than the glass universe, there is a lengthy repertoire here. So the first book was called Longitude, the true story of a lone genius who solved the greatest scientific problem of his time, followed by Galileo's Daughter, a historical memoir of science, faith, and love. Then The Planets, a discourse on the discovery, science, history, and mythology of the planets in our solar system. Then A More Perfect Heaven, how Copernicus revolutionized the cosmos. And last year, The Glass Universe, how the ladies of Harvard Observatory took measure of the stars. Now, The Glass Universe is, like the previous books, well-researched and well-written, and it concerns the history of a rather incredible period in astronomy. It's a story that is sometimes told, took us to the next slide there. Excuse me. So this book concerns the history of a period that we hear about perhaps in introductory astronomy courses, and those of us who are professionals in the field are generally aware of the basic historical situation, though not in anywhere near the detail to which we are treated in this book. And especially wonderful, I found, was the context and the social circumstances in which the historical developments took place, and intriguingly, the relationships among the various characters, all of them very major players in the development of science. So as an example, which I will read just a brief paragraph, early on in the book, she's describing the observations related to the star Mizar, which winds up being a quadruple star, and at the time was just being discovered as a binary. And if I can just read some of the text, it says, Miss Maury, who we will hear more about during the talk, could picture the Mizar pair as two wary combatants, circling each other while vying for advantage. Her distant vantage point made it difficult to distinguish the two separate bodies, impossible, in fact, when either one stood in front of the other along her line of sight. But Mizar's twin fighters were emitting light. As they revolved, their relative motions shifted slightly toward the blue end. As they revolved, their relative motions slightly altered the light's frequency. The approaching starlight shifted slightly toward the blue end of the spectrum, the receding starlight towards the red. And this is, to anyone who is an astronomer, we know exactly what she's talking about, and have probably not heard it described that way. So I found this interesting, and to those of you who are not astronomers, you certainly get the idea of what is going on scientifically. So one critic has described The Glass Universe as a fascinating, witty, and most elegant history, and I could not agree more. So please welcome Dava Sobel to the stand.
Good. So welcome everybody. I'm really very thrilled to be here talking about this book. I spent the day seeing some wonderful historic sites right here at Caltech in the archives. Got to look at a first edition Copernicus. Oh yeah, it's right here. And also got to go to the offices of the Carnegie Observatories and see some of their historic glass plates, which was a great thrill. The book is called The Glass Universe because the Harvard plate collection is really the star of the story, and made everything possible for the women who worked there. And people often ask me if The Glass Universe was an intentional play on the idea of the glass ceiling. Well, sure. The universe is a kind of ceiling. over us all, and the plate collection made it a glass universe, and the women faced something of a glass ceiling, but really not too bad. Really, as I'm happy to report, they were very much appreciated, recognized in their own lifetimes, and even became world famous in their own lifetimes. Quite a number of them. But it was an unusual time. Many things came together to create this situation, including the founding of some of the important women's colleges in the 1870s, including Smith College and Mount Holyoke. But at the same time, there was an objection to the idea of higher education for women. And the author of this book, Edward Clark, honestly believed that if a young woman spent these important years of her biological development going to college and studying hard, that this would have a terrible effect on her health, and that actually her reproductive organs would atrophy. You can afford to laugh, but this is what women were up against. And it took till the mid-1880s to debunk that idea. But at the Harvard Observatory, women played a role from early on. The wives, sisters, and daughters of the astronomers were just corralled into the work as computers. And they performed calculations. They were taught what to do without a higher education. They were taught what to do, and they were good at it. And so that opened the door to hiring women who were not part of the observatory family to come in and work. So it's a beautiful old building as it appeared at its dedication, and it was a wooden building. But the amassing of the plate collection eventually caused a brick building to be erected, especially to house them, because the director was terrified of losing this valuable collection. Women were did not have to have a higher education at first. They just had to be good at math. And in the back there, supervising the women, is Williamina Fleming, one of the ones who became quite famous. I'll tell you more about her later. And she originally started at the observatory as a domestic servant, and but went on to be given a position of great authority, which tells you something about the director, Edward Pickering, and how open-minded he was, and how willing to give people a chance and to just see how far they could go on their own intelligence. And here he is. He was only 30 years old when he took over at the observatory, and it was something of a scandal because he wasn't an astronomer, he was a physicist. And at the time, most astronomers were involved in astrometry, and figuring the exact positions of the stars, and that's what many of the calculations were about. But he had been a teacher at MIT, and that's a picture of his laboratory. So he created a teaching environment where the students learned on their own by doing experiments that he devised. And when women approached him and wanted to take the course and be in his lab, he let them in. So he had this very, very open-minded, open-armed attitude. And of course, he was interested in the physics of the stars. One of the projects he started at Harvard was looking at the relative brightness of the different stars, photometry. Other observatories weren't doing that, and he thought that would be really interesting work, important work. And so he invented a lot of instruments for doing that work. Harvard had a 15-inch telescope. You could still see the stars from Cambridge at that time. This is no longer the case, unfortunately. I like to think that's Pickering there in the chair, but of course, I have no idea who it is. So the idea of using photography was a big argument because many of the skilled astronomers thought that it was a gimmick and that how could a camera and a plate see as well as they could with their skills and experience. But as most of you know, the beauty of the photographic plate is that it can accumulate light over time, which the retina cannot do. So on long exposure photographs, stars would appear that no one had ever seen. And that's what finally carried the argument, that this was an okay innovation. And Pickering's younger brother was very interested in photography, was teaching it at MIT. And so they began to take pictures of the sky. Some of them are positive images, like this one. Most are negatives, so the stars appear as black dots on a white background. And many of the plates are about 8 inches by 10. But the real pioneers in photography were the amateurs, who didn't have to adhere to a professional program. So this is Henry Draper and his wife Anna Palmer Draper, and he was a medical doctor and taught chemistry at NYU. But he was a passionate telescope builder and astronomer, and he was the first person who succeeded in taking a photograph of the spectrum of a star. And as a chemist, he found this thrilling, because for centuries, people had just looked at the stars in terms of position, navigation, orbital dynamics of the planets, the stars as background. Nobody thought they'd ever be able to figure out the chemical constitution of the stars. So spectroscopy opened this area, and Draper said that spectroscopy had made the chemist's arms millions of miles long. So he and his wife decided they would give up everything what they were doing and devote the rest of their lives to photographing the stars one at a time, the spectra, and figuring out the different types of stars, to be looking at their spectra and trying to create a taxonomy of the stars. And just when they got everything set up to do this work together, he developed pneumonia and died. He was 45 years old. So she, having been his assistant for 15 years, wanted to carry on the work by herself, like get an assistant or maybe 2 or 3 assistants to take the place of Henry. But she couldn't set it up and make it work. So she approached Pickering at Harvard, who was a friend of theirs, and said, "I will give you my personal fortune." She was an heiress. "I will give you the money to do the work if you will do it in my husband's name." So Pickering was very happy about that prospect. She tripled the operating budget of the observatory at a stroke, and she was an active supporter for 30 years. So, and they carried on correspondence the whole time, a technical level correspondence. So this is a textbook example of a spectrum. So you get the nice colors of light and the dark Fraunhofer lines. But of course, there was no color photography then, so the spectra looked more like this. And really, the way Pickering photographed them, which was to put the prism at the light-gathering end of the telescope so that he could get hundreds of stars on every plate, not just one star per plate. So they looked like this. And the black dot is a penny, just for scale. But every one of those little tiny smudges is a spectrum. And so the women would look at those and give each one a classification. So the first classification, which came out in 1890, was by Williamina Fleming, and it included 10,000 stars. And her way of doing it was to just use the letters of the alphabet to distinguish the various categories. So here she is again, looking very stern. She was very stern, supervising her staff. So see how the plates are set up in those wooden frames, and then there's a mirror at the bottom, and the sunlight would come in and bounce off the mirror up through the plate, and they would have good illumination. And there's Pickering overseeing the group. I want to show you Pickering's desk, which has survived just because I think it's such a great idea for the busy executive. It's round, but it's 25 feet of desktop service. And you can have your different projects set up at different points along, and just give it a spin and round it. It's like a lazy Susan. And then the bookcase at the center spins separately. And this is now in the home of Sarah Schechner, who's the curator of historical scientific instruments at Harvard. And so see, she's put Pickering's photo there in the desk, in the bookcase. And she's promised me that she's going to put my book in there too. So here's Mrs. Fleming, who came to this country from Scotland as a young wife, and then found herself pregnant, and with her husband no longer at her side. So in her desperate circumstances, she applied for a job as a maid at the observatory. And the Pickerings immediately recognized that she was too smart to be the maid, and so they moved her over to the observatory and taught her how to do computing. And they helped her go home to Scotland to have her baby and promised her a real job if she would come back. So after 2 years, she came back, and she worked at the observatory the rest of her life. And she worked her way up to become the curator of astronomical photographs. And that made her the first woman to hold a university title at Harvard. The young woman is Antonia Maury, who was Henry Draper's niece. And she was the first woman to come work at the observatory who had a college degree. She was a Vassar graduate. And over there, a woman, the formidable-looking woman, is Maria Mitchell, who, after becoming famous as a comet discoverer, became professor of astronomy at Vassar College. And Antonia Maury had 8 semesters of astronomy with Maria Mitchell. So she looked at the classification system that Mrs. Fleming had developed and poo-pooed it and came up with her own system, which was much more complicated, but not as popular with people, probably because it was so much more complicated. This is Annie Jumpcannon, also a college graduate. She came from Wellesley College in 1896, and she'd been out of college for a number of years by that point. And she was the first woman who did her own observations at the observatory. All the others had done computing work or they'd been given the plates to analyze, but she was actually making observations. So the drawing of her at the telescope is from a children's book about her by Carol Gerber. And down at the bottom there, you see her in the physics lab at Wellesley. And the Wellesley physics lab was modeled directly on Pickering's lab at MIT, because one of the students who had worked with him went on to be a physics professor at Wellesley. So Ms. Cannon is the one who brought the classification system to the state most of you learned. You know, why do the stars go O, B, A, F, G, K, M? Because she had to take them out of the alphabetical order because of the patterns she recognized in the spectra. So that's how we got Oh, be a fine girl, kiss me. And so she would look at these plates, she would give every spectrum a number, and then she would just call out to her assistant the number and the letter she assigned, and she was fast. One of the great things I found in the Harvard University archives were 2 boxes full of her diaries. And that was a great resource to have, despite her handwriting, which really took some time to figure out. But I had worried a lot at the beginning about how to get at the personalities of the women, and materials like diaries, letters. Some people wrote their autobiographies, so there was a lot of original material to work from. It was very important to be able to photograph the entire sky, not just the northern hemisphere. So early on, Pickering sent a trusted deputy to South America to reconnoiter a site for a southern observatory. And this is where they started. Doesn't look very promising, but they were determined. It was very hard work, first to travel all around and climb all the mountains, then bring down prefab buildings and build roads to get equipment up to the mountaintop. But they eventually got it together, and this looks like a very respectable observatory near the town of Arequipa in Peru, in the lee of an extinct volcano, which actually turned out to be dormant. You'll notice only one of the buildings has a dome, so some of them were slide-off roofs, but that dome housed the very big telescope that Pickering had envisioned for this wonderful new site in the southern hemisphere. And he advertised that he needed $50,000 to build this telescope. And another heiress just stepped forward, Catherine Wolfe Bruce of New York, and wrote him a check. And there it is. This instrument still exists. When they much later, when they lost the weather at Arequipa, it moved to South Africa, and it was used there for a number of years, and then it was moved back to Harvard, and it's been at their Oak Ridge Observatory, packed in what looks like llama hair. But recently, the lenses have been taken out and set up in a new exhibit in the Science Center about scale. So the work at the observatory in the South was arduous, but people managed to have a good time and have picnics. The woman closest to me is Ruth Poulter Bailey, who was married to the director of the Southern Station, and he is the gentleman in the hat. So there's a woman next to her, and then the bearded fellow is Solon Bailey, who started as an amateur volunteer at Harvard Observatory, but became the trusted right hand of Pickering and then the director at Arequipa. And because he was going down there for years, he took his wife and they had a young child, a son, about 4 years old, and they took him too. And Bailey was especially interested in globular clusters. And let me just say how I appreciate the way astronomers name things. You know, you don't have to wonder, what did they mean by that? It's a globular cluster of stars. And they were especially interested in the great number of variable stars that they found in these clusters. And so to track them, they would make a grid on another piece of glass and put that over the photographic plate and then count all the stars in each square. And there are thousands of stars in these pictures. And of course, at the center becomes impossible, but they did the best they could. And then they would track them photograph to photograph to watch how the magnitude changed, the brightness of the stars changed over time. And this woman, Henrietta Swan Leavitt, used the plates from the southern hemisphere to make her great discovery, which enabled people to measure distances in space much farther beyond anything that had been possible before. And she was especially interested in this object, the small Magellanic Cloud. She looked at the large one too, but her reasoning was that probably everything there is roughly the same distance from Earth, so whatever looks brighter really is brighter. And then she watched the cycles of variation over time, and she made the very important observation that the brightest stars took the longest time to go through their cycles of variation. And she told Pickering about that. He announced it in a circular, and he gave her credit. And he was so excited that he referred to it as a law. And a few years later, after she did more detailed studies, she published it herself. And for years, it's been called the period luminosity relation. But for nearly 10 years now, there's been a movement to call it the Leavitt law. So pass that on. It's gaining, you'll hear it from many people other than me. So one of the things that happened almost immediately from her publication was an astronomer looked at the same types of variable stars closer by, put a calibration on everything, and was able to estimate the distance to the small Magellanic Cloud at about 30,000 light years. After Pickering died, Harlow Shapley, who had worked here at Mount Wilson, took over at the observatory. And he was also interested in the globular clusters. He had met Bailey at Harvard and been encouraged to look at them with the wonderful instruments here at Mount Wilson. And Shapley used the globular clusters and Miss Leavitt's discovery to gauge the size of the Milky Way. And it was so big that he was sure it was the sum total of the universe, that there were no other galaxies. And this was the big debate in the 19-teens and early 20s. Was the Milky Way the universe, or were there numerous galaxies? So while Shapley was here in California, he got interested in ants. And he actually wrote numerous scientific papers about ants. He studied their behavior, what made them speed up or slow down. They were very temperature sensitive. And I just wish he could have seen this cartoon. This is a New Yorker cartoon. and the caption has been cut off, so it looks like one of those contests they run now. But I'm going to tell you the caption. Kind of makes you feel small, doesn't it? So Shapley really wanted to start a program of graduate level education in astronomy. Harvard had not had that before, and he was chiding the people at Harvard that, you know, if they'd had a department, they could have promoted somebody from inside and not have to import a Missourian from California. So because of the history of the women's involvement and the women philanthropists who were providing money, a relative of Maria Mitchell's had set up a fellowship fund for young women to work at the Harvard Observatory and also work at the Nantucket Observatory at Maria Mitchell's home on Nantucket Island. So the large image is Margaret Harwood, who was a Radcliffe graduate, and she was working at the Harvard Observatory, and she got one of these fellowships, and they loved her so much at Nantucket that they made her the permanent fellow and director of the observatory, and she was there for more than 40 years. So the philanthropist, the relative of Maria Mitchell, whose name was Lydia Hinchman, set up another fellowship program. She actually funded several grants, always with the goal of bringing young women in to work at Harvard, and then they could go on for a real job somewhere else. And one result of that was the infiltration of observatories all over the country by these young women who'd had training at Harvard. But another effect of it was that it was the only fellowship money that Shapley had at his disposal to bring in graduate students. So that meant, since they were specifically earmarked for women, all the first graduate students were women. So at the top is Adelaide Ames. She was the first one to come as a graduate student. She earned a master's at Harvard. And then Cecilia Payne, the bottom picture, later Cecilia Payne Gapashkin, she came from England because she'd been told there was no future for her as an astronomer in England, and this fellowship money and educational opportunity was available. And of course, she knew of the work of Miss Cannon and Miss Leavitt and the others, and it was very attractive to her. So she came, and Shapley recognized her tremendous talent and pushed her to continue for a PhD. So she was the first person to earn a Harvard PhD in astronomy. Not the first woman, the first person. And in the course of her doctoral research, and she was also attracted by the plate collection because she knew it would be an important resource for the work she wanted to do. And she was looking at the relative abundance of different materials in the stars, and it seemed to her that the hydrogen was about 1 million times more prevalent than anything else, which seemed crazy because people were expecting, since the materials were the same as on the Earth, people thought the proportions would be the same. And so she was advised not to make too much of this finding. Shapley worried about it. He referred her to Henry Norris Russell, who said it's impossible that the hydrogen is 1 million times greater than anything else. But so in her dissertation, she said that that's what she had found, but that it was probably a spurious result. But it took only 4 years for the whole astronomical community to come around to do further work and be convinced that, you know, it really is mostly hydrogen. So that was a good dissertation. So this is most of the gang. Miss Cannon's in there, Miss Leavitt, and this is the famous paper doll image. It's called that for obvious reasons, and I think it gives the sense that there was something demeaning in the way, or the women were somehow demeaned, but it's really not the case. Not only were they always credited for what they did, they became members. They were members of the American Astronomical Society. Miss Cannon was an officer. They were foreign members of the Royal Astronomical Society, the French, the Mexican. So they were really known and appreciated in their lifetimes, and I think they felt that very strongly. I think the only thing they complained about was the lower salary. And there's definitely record that they complained about that. And things haven't changed all that much, have they? The story you often hear about Pickering is that the way all these women got to work there was one day he was dressing down one of his subordinates who was doing sloppy work. And he said to this young man, my maid could do a better job. And he brought her in. And you hear this story all the time. But I want to say that having read Pickering's correspondence over a period of many years, he was the most polite person who ever lived. And the idea that he would treat anyone who worked for him in a rude manner is completely out of character. I would bet anything that never happened. And he wouldn't have referred to Mrs. Fleming as my maid. I think that would also have been, he would have considered that disrespectful. So this is where the plates live now. That is the same woman. It's just two pictures of the same person. That's Lindsay Smith, who is the acting curator now of the collection. So the record books are still there. Anybody looking for a good citizen science project, the record books are being digitized. They need people to type in. I think I've started. I haven't really devoted myself to it yet, but I figured now that I can read Miss Cannon's handwriting, shouldn't I be doing that? Yes, of course. And then I just want to show some proof of how famous they were. Miss Cannon, within just a couple years of her death, wound up being a Wonder Woman of science. This was Wonder Woman comic books. They used to have a feature, and there she is. Here is a modern website called Rejected Princesses. Women who are too awesome, awful, or offbeat to be in a children's movie. And so there's Pickering holding the ladder for her while she's making her observations. And then recently, the original writers of Carl Sagan's Cosmos redid the series with Neil Tyson as the host. And there was an episode devoted to the Harvard women. It was called Sisters of the Sun. And so this is Miss Cannon in the foreground, and it's Miss Leavitt. So they're definitely having a moment. Here they are again. You can get this on a T-shirt. So Miss Leavitt looking at her variable stars on the plate, and Miss Cannon with the classification, and then Miss Payne with her discovery about hydrogen and helium. How many people have seen Hidden Figures? So I like to say that my ladies are the grandmothers of the Hidden Figures. And standing happily next to the poster is Alyssa Goodman, who is professor of astronomy at Harvard. And notice her T-shirt. It looks like the NASA meatball, but it says nasty. And so she was one of the people I asked to read the manuscript of my book as a technical expert. And she got so agitated about the situation. She said, you know, I work here, I've heard these names, but I always thought it was some just a cute, quaint story. I never realized they were actually doing science. So you should come up here and teach us our history. And she arranged for me to have the book launch at the observatory, which was a great thrill. And I've since met the author of Hidden Figures, and we've had a conversation. There was also another book about women computers that came out last year called The Rise of the Rocket Girls, right about the Jet Propulsion Lab. So here's another photo. That's Margaret Harwood sitting on the floor, Cecilia Payne at the drafting table, Antonia Mori in the foreground in the dark dress, and that's Miss Cannon, who still can't look up from the plate. She's just working all the time at the back. And it's a great, just a great tableau. If I were going to write a play about the women, there have been plays written about them, not by me, but that would be the opening tableau. I would have them all arranged like that. And in this strange moment we all find ourselves in of a really frightening anti-science attitude in this country, and the rise of alternate facts. I feel really good, better than I thought I would, about writing a true story about science, a true story about women in science. Because so many people don't realize that they have women role models in science. Most people cannot name any woman scientist other than Marie Curie. So we're going to change that. All right, well, I'd be happy to take some questions. Talk about